Hello, my name is Ewan Slater. I'm a director in the EMEA OCI Centre of Excellence. I'm joined for this session by my colleague Raoul Gameth, who is also a director in the EMEA OCI Centre of Excellence. Raoul, welcome and great to have you on the call.
Thank you, Ewan. My pleasure to share this call with you.
So, this is one of a number of sessions that we have put together to help people understand how they can move to enterprise cloud with Oracle. The goal of this particular session is to discuss governance, how you can look at what's going on in your cloud tenancy, how you can start to explore more complicated architectures like hybrid, like multi-cloud, and how you can control and manage your organization and its costs to ensure that you get the maximum value from the platform. If you've watched the sessions so far, and I strongly encourage you to watch all of them, you will now understand what OCI is, that it's a Generation 2 cloud, that it is available in multiple data centers across the world, that it has a number of unique features. You'll understand its security model, that it is security by default, a security first approach. And you've likely already deployed your first application. This session is going to go beyond that. And we're going to look at how you can start to log things that happen in your application, how you can start to react to events, and how you can start to look at more complicated architectures, like, say, spanning across multiple clouds, and how you can administer and optimize your usage of the cloud. Your first application deployment probably looks something like this. You have a VCN, a virtual cloud network, created within a compartment, which is probably, hopefully, a subcompartment of the root rather than created directly in root. Within that VCN, you'll have subnets, and you will have deployed your, say, a virtual machine with your application on it and maybe your database, and probably these are in separate subnets. And then you've exposed the application to the outside world through a load balancer. So our application is now up and running. We're flying. But what if something happens that we weren't expecting? What if an anomaly happens? What if it crashes? Now, if we were in an aeroplane, we would look at the flight recorder. That would show us the data. That would show us the things that had happened up to this event taking place. In OCI, logging is your flight recorder. So here we can see a view from the OCI console. The console is constantly under development. So if you go to this console and you see some slightly different buttons, depending on when you watch the video, don't be alarmed. However, the important thing is that you would see that you have the log. In this case, it's called parking gate execution. You would see, if you look under the log details, that it's a service log. It's generated by a service, that it's generated by the API gateway service, to be precise, and that it is in the log group storage logs with a retention period of a month. You can see that it looks at a number of events that happened on the 10th of March, 2021, a number of successful requests to a function, which was actually to control a parking gate, whether you allowed a car in or not. And we can then further start to drill into the information about each of those log entries. So if you click on one, you'll see that the information opens, it drops down, and you'll see all of the different information in there. We can see that this log event has a level of info. The message is that there was a successful request sent to the function, and we can look at things like the log ID, the log group ID, what the exact time was, all of these different things that happened within that execution. So what OCI logging gives us as a service is a way to see all of the things that have happened, all of the things that have been written to logs, and to collect them together and manage them, not just for the OCI services, where it will collect the service logs, as you saw for API Gateway, where it will collect the audit logs, but also customer generated logs. So things like application logs, security logs. And then we can take these and we can search on them and we can analyze and we can even take action against them. So we might, for example, write them to a stream or invoke another function, depending on what's in the log, or just write them to object storage for posterity. So this gives us an ability to view all of our logs through a single window or a single pane of glass, to have them in one location, to use the Fluent D agent to help us acquire those logs, to enrich events with additional metadata if we need to, and to manage logs with our log groups for access control. Now, log groups are logical containers to handle and manage your logs. So your log is within a log group. And we can set permissions on that log group. Now, the permissions might be set at the compartment level, or they might be set at the log group level. So you might, for example, want to restrict logs for a particular application. They might contain sensitive data down to a specific set of users. Or you might have the logs for the production environment accessible to a different group of people than the logs to the development department. And when changes are made to permissions or logs are accessed, that is in fact audited. When we look to search our logs, there's a couple of ways we can do it. There's a sort of graphic wizard-based approach I'm showing here, where I've gone and I've selected me, my compartment, storage logs, and the parking gate execution log. And that's what you see when you've run that search, which is similar to what we saw before. There's also an advanced mode you'll see there, and that allows us to start defining our queries at a more granular level using a query language. So it's SQL-like, it's not SQL. It allows us to search across multiple logs or data sources within a region. And it also provides functions that we can use to slice and dice the data. So for example, we can filter, we can check the average or the minimum or a sum. And it enables us to build up more complicated queries. We can also save our searches and then be able to rerun them again at a later time or specify a query frequency. Some examples of using the search language are here. So this is searching an application security log. We might want to search for entries where the log level is error or info. And in this case, we've specified that it's for a particular host, host 1. The second one, we want to order the entries in the application security log by their impact. So the higher the impact ones will appear higher. We can look at those, single them out for attention. Or we might, in the bottom one, use a function, in this case concat, to put the host and the us.oracle.com together to give us a fully qualified name. As I said, logging can integrate with other Oracle services. We can write to streams, which we can then consume and process in additional ways. We can archive them to object storage. We can invoke a serverless function or emit a metric that's then used by the monitoring services. So it's kind of an if then this, if that then do this type of rules engine. Based on those rules, we can take actions, we can send notifications, as I said, we can emit metrics. And with the integration with object storage, we can give you options to export the logs to archive storage, or we can stream them to other systems such as Splunk, for example. Now, if logging is your flight recorder, metrics is your multimeter. There are a large number of system metrics available with OCI. if you look at the documentation for every OCI service, you will see it generates a set of default metrics. You can also create your own custom metrics. So for example, with compute, you would be typically looking at something, say on an instance, you could be looking at the memory consumption, you could be looking at network consumption. If we look at a network here, so you see on the top right, we've got metric namespace OCI VCN. We're looking at a network and we're able to see things like, the packets from the network, the packets sent to the network, the ingress packets that have been dropped by the security list. And we can aggregate metric streams together. We can drill into metric namespaces and add particular dimensions. So the monitoring service gives us it's a fully managed out-of-the-box monitor for cloud applications and services. We choose the metrics we want to use in the same way that with a multimeter, you choose which things like voltage or current you wanted to measure. And you're able to take metric data about the health and the performance of your resources. Again, like logging, there's a query language that you can use to create more detailed queries. And again, we can integrate with notifications and send messages via email or PagerDuty. So to take a graphical view of this, on the left, we have the customer applications and services and resources that are generating custom metrics. We have the Oracle Cloud Infrastructure services that are generating their standard metrics. That metric data can be collected and aggregated together. We can then set triggers and alarms based on thresholds. So you might say, if my storage on a block volume is over a certain capacity, then please send a message so that somebody knows that they need to go and do something. Even better, you can have a function, say, that would be triggered off the basis of that alarm. So you've got you can set up automation to take action on the basis of that threshold being exceeded. Typical monitoring use cases, we're measuring resource utilization because we want to optimize usage. We want to be able to monitor trends. We want to, as I say, detect things that are going wrong in the system. If some CPU utilization goes over a certain threshold, if we've used up a certain amount of our storage, or to quote from Star Trek, the "it's dead, Jim" scenario. We get a notification if no metric is generated for a resource in a particular period. We might also want to use a breach of the threshold to trigger some kind of auto-scaling event. So monitoring is a very powerful tool. We can use the metrics, we can monitor them, we can take action on them. Now, if metrics are a multimeter, logging analytics is our head-up display. And in the same way as when you're flying a fighter, you want to be able to look forward and see all of the relevant data displayed for you in front of you without having to look down at the instrument panel. Logging analytics gives you a way to create that kind of dashboard to show business critical data that you can then use. And at this point, I'm going to hand over to Raul. Raul, over to you.
Thank you, Iwan. That's right. OCI monitoring capabilities are really powerful, but in occasions, we will need to manage huge volumes of logs and extract insights from them. Log analytics is a tool integrated in OCI console to provide visual analytics capabilities. You can inject OCI logs and design amazing dashboards to transform the data contained in the logs in visual information more easy to analyze and understand. Tools like Log Analytics or most advanced observability platform are key if we plan to open the multi-cloud box of chocolates. But what does multi-cloud really mean? And why do it? Well, multi-cloud means bring the customer the freedom to choose and use the best cloud provider to run each of their workloads. Basically, the customer can split their application into different layers and even run each of these layers into different cloud providers. What happened with the on-premise facilities? You can think in on-premise like some type of private cloud provider. So at the end, you can manage all environments, public and private, as a cloud provider. And how to connect multiple clouds to OCI? Our tool or service to provide this type of connectivity is called FastConnect. FastConnect works with connectivity partners in order to provide end-to-end connectivity. It's agnostic. It means that we can work with all providers, not only the list of providers that you can find as certified providers in each region. FastConnect has something that is unique at this moment in the market, that is a flat fee rate per data transfer. It means that it doesn't exist hidden cost, no extra data charge for ingress or egress traffic. And why use FastConnect? Maybe exist other reasons? Yes, of course, if you need performance, if you need security, or maybe high availability, get your connectivity covered by SLAS, or more simple reason, your sensitive data cannot traverse the internet. Maybe you are thinking that implement a multi-cloud strategy is something really difficult or complex. In fact, it's not true. Actually, connect the dots is really simple. Let me show how to implement this type of architecture. If you want to connect on-premise facility here in the left to one of our OCI regions, we have multiple regions across the world here in the right, you only need to provide connectivity between the on-premise facility with the connectivity partner's point of presence. From here, from this point of presence, you can use the connectivity partner backbone in order to reach our OCI regions. We have multiple points of presence in each region in order to provide high availability. If you really want to build a multi-cloud architecture working with other cloud providers, you can reuse this connectivity across the backbone of the partner in order to reach other cloud providers. And in that way, you can, in a very easy way, split your workloads into the different cloud providers. OCI has been designed from the root with multi-cloud in mind. A perfect example of this mindset is our agreement with Microsoft Azure. Basically, in such a location where we share co-location, we implement a direct connection between both clouds. In that way, we can provide really low latencies and we can avoid charge per data transfer. It means that no data transfer for egress or egress in any of the clouds will be applied. We have also Terraform script to automate the provisioning and the deployment, and we also work in a shared support model in both companies. Taking a look to the architecture, basically you can see in the left OCI using our DRG, that is our virtual network device where our FastConnect are attached. And you can see in the right the Microsoft Azure tenant using the virtual network gateway and implementing the express route. So as you can see, there's no exist a third-party connectivity provider providing this link between our DRG and the virtual network gateway. We only have working together our FastConnect and the express route. And remember, no extra data transfer charge will be applied egress or egress. Cloud open in front of us a world of possibilities to design and deploy our workloads. It's also important to keep costs under control in our trip to the cloud. And OCI has a really easy and transparent cost model. Once you start working with OCI, you will have two different consumption models: pay-as-you-go and annual flex based in universal credit. Pay-as-you-go is really simple. Basically, you only pay for usage with no upfront commitment. In annual flex model using universal credit is a really flexible and special model. You will have a 1-year minimum term, but you will get all the flexibility of the universal credit. A universal credit means that you don't need to know in advance if you will deploy maybe compute or storage or maybe serverless or cloud native resource, because you can use the universal credit to buy all the resource across OCI. You can also use your license implementing the bring your license model. There are some factors that impact in pricing that if you are using OCI, don't need to be scared about it. For example, speaking about resource, the pricing of those resources are linearly. It means that if you are using a smaller resource, you will pay less, and if you move to bigger resource, you will pay a little bit more, growing linearly. All OCI regions have the same pricing across the world for almost all the services. We don't have hidden cost. And speaking about networking, we don't have ingress cost, and we eliminate the data transfer charge for egress for almost all situations. Let me deep dive a little bit more in our pricing model and explain the data transfer cost with more detail. Here you can see a typical OCI region with 3 availability domains, and we plan to move data from one virtual machine to another virtual machine. Both virtual machines are located in the same availability domain. Basically, the data transfer between both virtual machines are totally free. It means that inside the same availability domain, the ingress and egress traffic are totally free without limit. If we plan to move data from availability domain 1 to availability domain 2 or 3, inside the same region, the ingress and egress traffic is also free and unlimited. It means that no charge will be applied for data transfer between resources located in availability domain 1 to availability domain 2 or 3. If you plan to connect and move data from OCI region to an on-premise facility or maybe to other cloud provider using our fast connect services, you will have also a totally free and unlimited data transfer rate. It means that no ingress charge will be applied and not egress charge will be applied. It means totally free. If you plan to move data between different regions inside OCI using our backbone, basically you will see that the ingress traffic to the region is free and unlimited, and the egress traffic of the region will be charged with the price that apply to this specific region. If you plan to move data from one region to other location over the internet, you will have a fully flat free rate, and you will have a egress charge starting from 10 terabytes per month. It means that the first 10 terabytes per month of egress traffic will be also free. Jumping into the governance part, OCI has something that is totally different from other cloud providers. The compartment is a logical entity, it's a collection of related resources, that help you to isolate and control access to your resource. After creating a compartment, you will need to write at least one policy for it. Otherwise, it cannot be accessed except obviously by administrators or users who have already permissions to the tenancy. Here you can see a typical example of policy granting access to manage instance family in compartment called Project A. You can use the compartment in different ways to build the governance model that better work for you. In addition to compartments, OCI implement tags. You can attach tags not only to compartments, also to any OCI resource in order to enrich this resource with metadata that you can use to implement a governance strategy, to enforce security, and maybe to implement a better cost tracking strategy. Something that are really useful in order to keep costs under control are budgets and alerts. Basically, a budget is a monthly threshold that you define for your CI spend, can be set on cost tracking tags or compartments, and track all spendings in the cost tracking tag or compartment and any child compartment. You can define email alerts that get sent out for your budget. Those alerts are evaluated every 50 minutes and can be triggered when your actual or forecasted spending hits the number that you define. Basically, here in the screen, you will see that you can define the threshold type and you can define the threshold metric based in actual spend or forecast spend, and the threshold type based in percentage of the budget or absolute amount. Another tool that OCI provides in order to keep costs under control are the quotas and limits. By default, each OCI service came with a protection limit to avoid accidental charge. Obviously, you can raise those limits to something higher when you feel comfortable with OCI governance model. You can also define quotas. Quotas basically give tenant and compartment administrator better control over how many resources are consumed in Oracle Cloud Infrastructure, enable administrator to easily allocate resources to compartment using the console. OCI has also a subscription sharing model that lets you link tenancy. Once the invitation is accepted, the linked tenancy starts to consume universal credit from the parent environment. You can see the tenancy consumption in the cost analysis. Taking a look to the cost analysis dashboard, you will see that this is really easy to use visualization tool that lets you track and optimize your Oracle Cloud Infrastructure spending, that lets you filter cost by date, by tags, by compartment, etc. The trend lines show how spending patterns are changing, so it's a really friendly and useful tool. Congratulations, you are now expert in OCI governance. If you want to know more about OCI data platform and management, please keep in touch and engage with the step 5. My colleague Juan and me want to say thank you. If you want to know more, you can reach cloud.oracle.com, start a trial, maybe play with the live labs on OCI, or feel free to contact your Oracle representative for further support.